Good morning everyone and welcome to our presentation. First of all, let us thank you for all coming here today. We will be presenting vector and scalar in architecture.
Before that, let me introduce my group mates to you. First, myself, Yashi Gopinathan, and my metric number is 01DTK23F1065. Second, Muhammad Adib Daniel Kamaruddin and his metric number 01DTK23F1066. Last, Jagannath Pillai Anak Lelaki S. Kartikesu Pillai and his metric number 01DTK23F1048.
In our presentation, we will be focusing on three major topics, which are introduction of vector and scalar, application of vector and scalar in architecture, and last, problem solving involving vector and scalar architecture. Scalar have only magnitude, while vector have both magnitude and direction. Scalar can be added, subtracted, multiplied, and divided using a regular arithmetic, while vector require vector operation. Vector represent quantity with both magnitude and direction, while scalar represent quantity with only magnitude. Understanding this distinction is important in science, engineering, and mathematics.
And for vector are used in architectural drawings and plans to represent directional information such as the orientation of a building on a site, the direction of sunlight for passive solar design, or the direction of prevailing winds for natural ventilation and strategies. We're presenting you about application in architecture. Like scalars and vector have various applications in architecture. Here, let me tell you a few examples. In scalar are used to represent quantities such as dimensions, areas, volumes, and weight. They are essential for accurately measuring and specifying the size and the scale of architectural elements such as room dimensions, building heights, and material quantity.
Now, I will be talking about problem solving in vector architecture. Let's see the question. The diagram shows a scalar triangle ABC with a vector of AB equals to A and vector AC equals to 2B. The point D is positioned on the line BC such that BD ratio DC equals to 3:2. The point E is positioned on the line AD such that AE ratio ED equals to 1:2. Find an expression for the vector AE. Let's see the solution. First, we can find the vector of BC. To find the vector of BC equals to BA plus AC. But we don't know the value of BA, but we know the value of AB. So we need to convert BA to AB. So when we convert, vector of BC equals to negative A plus 2B. Then we can find the vector of BD. To find the vector of BD, from the question we know that vector BD equals to 3/5 vector BC. So BD equals to 3/5 vector BC. The value of vector BC, we already find the first part of the question, is negative A plus 2B. So multiply each and every term. 3/5 times A equals to negative 3/5A plus 6/5B. Next, we need to find the vector of AD. To find the vector of AD, we need to have the value of AB plus BD. So So we know the value of AB from the question, it's A, and the vector of BD we know from the second part of the question, which is negative 3 over 5A plus 6 over 5B. So the vector AD now is 2 over 5A plus 6 over 5B. Finally, to find the vector of AE, we know that AE equals to 1 over 3 AD. So AE equals to 1 over 3, and the vector of AD we already know from the third part of the question, which is 2 over 5A plus 6 over 5B. So multiply 1 over 3 times 2 over 5A and you will get 2 over 15A, and 1 over 3 times 6 over 5, you will get 2 over 5B. So thus AE, vector AE equals to 2 over 15A plus 2 over 5B.
In summary, scalar have only magnitude, while vector have both magnitude and direction. Scalar represent quantities like temperature and mass, while vector represent quantities like displacement and force. Understanding the distinction between vector and scalar is important for accurate the description and analyze in various fields.